Hello, everyone. Welcome to the KSEA Distinguished Guest Series. My name is Young Kim, Professor of Physics at the University of Chicago and President of the Korean American Scientists and Engineers Association, KSEA. The theme of today's guest series is a really hot topic these days, GPT, a cutting-edge AI text generation algorithm. I'm sure that all of you have heard of that, probably more about ChatGPT, which became a common word in our society. Today, we will learn about GPT and discuss impacts of GPT on science and engineering and technology, and also discuss how GPT revolutionized the way we work and delve into its broader social implications, shaping the future across the multiple domains. Our distinguished guest today is Professor Kangwook Lee. Professor Lee is an assistant professor at the Electrical and Computer Engineering Department and at the Computer Sciences Department at the University of Wisconsin-Madison. He also leads deep learning research at Krafton, which is a South Korean video game company. Professor Lee received his PhD in 2016 from the Electrical Engineering and Computer Science at UC Berkeley. He then went to the Information and Electronics Research Institute at KAIST, Korea, as a postdoctoral scholar and then a research assistant professor. Professor Lee is the recipient of the IEEE Joint Communications Society Information Theory Society Paper Award in 2020. IEEE is the world's largest technical professional organization dedicated to advancing technology for the benefit of humanity. Professor Lee also received KSEA's Young Investigator Grant Award last year in 2022. Now, please join me in welcoming Professor Kangwook Lee.
Welcome. Thank you so much for kind introduction, Professor Kim. And I'm super excited and honored to give a talk today. GPT, as Professor Kim mentioned, is literally becoming one of the most hot topics of today. And it is going to change, I strongly believe, it is going to change the way we work and we live. And I think it's really important to know what it is and how we should prepare for the changes we are going to see. So with that, I'm going to start sharing my screen. So I hope everyone can see the full screen wall. Good, thanks for the thumbs up. All right, so I guess I prepared the presentation for about 25 minutes, but I'm also happy to be interrupted anytime if you have any questions. I try to make the presentation very easy to understand. So I hope this is accessible to almost everyone here, but feel free to interrupt me if you have any questions. All right, so title of the talk is GPT, Transforming Science, Engineering, and Beyond. I'm Kangwook Lee, Assistant Professor at UW-Madison, and also I lead deep learning research at Krafton. So today's talk is about GPT, and GPT is a short for Generative Pre-trained Transformer. I'm going to explain what they mean. But before we talk about what GPTs mean, the final message that I want to deliver today is they are literally revolutionizing the fields of science and engineering right now. And the way they revolutionize these fields is they actually offer almost or near human level intelligence in many places we are going to see. So this talk, I'm going to talk about 3 different parts. And I'm going to actually emphasize a lot on the first part. The first part is the basics of GPT. So what is GPT? And all I want you to take away today from my talk is, I hope you all understand how GPT works and what GPT means, and what is the fundamental ideas behind the scene. And then I will move on to the applications of GPT in science and engineering. And as a scientist and as an engineer, how we should prepare for the changes that we are going to see. And lastly, I'm going to also talk about more broader applications and implications to our society, mostly about ethical and societal implications. With that, I'm going to start with the first part. What is GPT? So to briefly talk about what GPT is, I have to first describe what AI is. AI, I guess almost everyone knows what AI is. It's a machine that does something intelligent. It's always called, anything that does intelligent is called AI. So that's the biggest set. Within the AI set, some portion of the methods are called machine learning. So machine learning is a subset of AI methods. And machine learnings are those that actually learn something from data. So anything that you learn from data, they are called machine learning. Deep learning is also a subset of machine learning, which actually uses something called deep neural network. And among those many deep learning ideas and techniques, GPT is a particular subset of deep learning. So I guess we've been hearing a lot about deep learning in the last decade, and GPT, you can see that as one small subfield here. In fact, more technically, GPT is kind of brand name, not a real name for the field. The field or the general techniques name is called large language model, but GPT is a particular large language model branded by a company called OpenAI. But I'm gonna just exchangeably use GPT and LLM large language models today, because GPT kind of became the most popular large language model in the world. All right, so what GPT is, or how does it work? In fact, GPT is probably the easiest way to explain GPT is nothing but a machine or an algorithm that predicts what the next word will be given the input text. So let me explain what that means. So think about a function or black box, which takes a text, a free-form text as input, and output the most likely or the most probable next word that follows this input text. So consider this example. So the input text here is biology is a natural science with a broad scope, blah, blah. For instance, all organisms are made up of, and the text ends here. So the goal of the next word prediction task is to figure out what the most likely word should follow this text. So I guess everyone here can guess the next word. The answer is cell. So all the organisms are made up of cells. So that's the next word prediction task. Another example here, here's Professor Kim's pitch, which is on the KSEA webpage. So she wrote, I'm honored to serve as the 51st president of KSEA, and so on. And the last sentence is, it has built strong connections between the US, and the sentence ends there. So can everyone guess what the next word will be? Well, we know that this is between US and, so the next word should be and, I guess. Adam made a correct guess too, great. But then, so GPT, assuming that GPT can guess the next word correctly, in fact, if you iteratively apply the same algorithm again and again, you can also guess the next word. So let's say now we correctly guessed the next word, which was and. So you feed it back to the input text and concatenate it. Now the input text also contains the and. So and then if you apply the same function again, the next word prediction would be Korea. So by applying the same idea again and again, you can keep generating the next words, sequence of next words, which is basically completing or writing an essay if you wish, depending on how many times you iterate the same black box. So again, GPT's the fundamental operation is just predicting one next word. And depending on how many times you iterate the same operations, you can actually write an essay, you can write a full program, and so on. So I'll talk about what that means. All right, so the cool thing about next word prediction is, turns out, nobody expected this to be the case, but turns out that next word prediction is almost becoming probably the first the universal interface to mimic general intelligence. So let me explain what that means. If you go Google and search for the term IQ test, and if you look at the first search results, these are the search results. These are the typical IQ tests we know. There are a bunch of sentences given and numbers and alphabets, and the task is to figure out the missing blank at the end, and so on. So these are, if you actually search Google IQ test on Google, and if you go to the image tab, all the IQ test results questions are like this one. You're given some patterns and figure out the patterns within the given context and figure out the missing last word is actually considered as one of the most standard way of measuring humans' intelligence. So in fact, if a machine can predict the next word very well, then we probably should consider the machine is actually pretty intelligent. That's what I mean by a universal interface to general intelligence is actually next word prediction. Let me give you another example. What about translation? Well, can we say translation is also next word prediction? The answer is yes. So let's say I want to predict or translate a word chair into Korean. The way I translate or convert this translation problem into a next word prediction is as follows. So just write down a few examples: apple, sagwa, and we know that apple and sagwas are paired like as a English-Korean pair. Pencil and 연필, that's another pair of English and Korean pair. So now if I give you a chair, an intelligent human would I'm expecting you to complete the last word with the Korean translation of chair, right? So that could be a sort of IQ test for human beings. And in fact, what's crazy about GPT is if you give the same question to GPT, then GPT will guess the correct answer. They will return 의자 as an output of this question. So, well, again, GPT was only trained to predict or build or designed to predict the next word. But as a result, it is able to do translation. In fact, it is really good at translating Chinese, English and Koreans, and it actually became the best performing Korean English translator as of now. Even though there are so many specialized translation specific programs, GPT-4 is achieving the state-of-the-art translation performances. What about just generic question answering? Well, so let's say you wanna answer this question: what is the difference between science and engineering? The very generic question, free-form answer is expected, but still, you can just write down the questions and just leave the answer with the blank, and the GPT will fill the blank and answer this question too. Let me just go even wilder. What about classifying an image? In fact, one of my recent research, we tried this task like this. We showed that if you have an image, you can literally write down the pixel values of the images and ask the model to classify whether this image is representing which object this image is representing. And in fact, this texture representation of an image doesn't lose any of the information. And if you, as a human, for instance, as a human being, if I'm given this question, I can literally redraw the image on a paper and answer this question. So technically, even though I'm doing probably something very dumb, I'm just making the image into a string of text and asking this question, but still the whole point is the text interface is kind of universal interface to represent any kind of task that we want to solve. There's a great question by Eric. I'm gonna answer that question at the end of the talk. Great question. All right, so that's about how universal next word prediction is. But then how do we train that? The training is the process of looking at the data which contains the questions and answers. For our case, we want to develop and learn a machine that predicts the next word. So what we need is a pair of input text and the output ground truth next word. And we need a large number of pairs to train such a model. The question is, how do you find them? In the standard machine learning or standard deep learning problems, collecting this training data set was the most expensive and time-consuming process. But ironically, this problem, the next word prediction problem, the following simple idea has easily solved the problem of collecting data. First, you just take a random text from the internet. Just go to a random website, copy and paste one sentence, pick a random location in the middle of the text. In the middle of the text, you grabbed from the internet and break it into halves. Everything before the breakpoint becomes the input. The next word that follows the breakpoint becomes the ground truth answer. And now you have one pair of input and output. You keep repeating this process again and again on the internet, and then you can collect as many as possible pairs, given enough time and compute resources. All right. So GPT again is the next word predictor trained on 300 billion pairs by a private company called OpenAI, and after this training, a really expensive training process, the model is able to make almost perfect next word predictions as we see these days, and that's the underlying engine behind ChatGPT and all these variants of ChatGPT models we are seeing these days. All right, so I'm gonna just quickly go over the history of GPT. It's been just 5 or 6 years that the underlying neural network architecture called Transformer was introduced by Google in 2017. OpenAI took the architecture and started using this model to architecture to train the next word predictor called GPT. And they have improved this version from 1 to 2, 3, and 4, mostly by increasing the amount of data and compute resources that go into the training process. And GPT-4 is what we are seeing these days. And in fact, GPT-4 has also has an increased modularity, input modality, which is the previous versions can only see the text, but GPT-4 can see both text and images. So let's take a look at a few examples showing how smart GPTs are. So these are the GPT-4's scores on some of the popular exams that we take. So the first thing is the bar exam. And you see that GPT-4 is having like top 10% percentile compared to the human. And LSAT also again about top 12%. SAT math again top 12, top 11. GRE Berber is like top 1%. USA BO is the USA Biology Olympiad, and that's like almost like top #1 in the US. And you can see that also it can pass the AP calculus and physics too. All right. Well, another interesting thing is, even though most of the data that GPT is trained on is based on Korean English data set, the performance of GPT on other languages other than English is also pretty good. So if you look at the blue bar here, so here's some number that represent how good GPT is at solving some language-related task. GPT 3.5, that's the performance of the model that we had in January of this year, and we were already surprised by how good they are. But the new version, GPT-4, they launched in March, 2 months later than that. The performance of GPT-4 is way better for sure within English. But then what's even more surprising is GPT-4's performance on other languages, including Korean and all the other languages, are better, higher than the performance of GPT 3.5's English performance. So in other words, if you were satisfied by the performance of GPT 3.5 when you are dealing with, when you are testing their English performances, GPT-4's performance on the other languages are better than that English performance that you have seen before. So you should check out GPT-4 if you haven't yet. So for instance, Korean performance is way higher than GPT-3's English performance. As I mentioned, GPT-4 can also see the image. So you can see that given this image, GPT-4 can explain why this image is funny. You can see that the input is this, the input is the question, followed by this funny image. And the answer generated by the GPT model is the image is funny because the charging cable looks like the old VGA connector. Because the model can see the image, you can literally copy and paste and drag and drop the image from the SAT exams or any physics exams too. This is a physics problem that college student should be able to solve, and GPT-4 can also solve and can generate a reasonable answer, step-by-step answer to that question. Now, what about paper? So you can just take a screenshot of the paper, of multiple pages of the paper, and ask the model to take a look at the paper and summarize for me. Then the summary given by the model is a pretty accurate summary of the paper. What about this? Another funny meme example. You just look at the, this is the meme where someone is posting a picture of this chicken nugget, and he says, they write, sometimes I look at the pictures of the Earth, even though it's not the picture of the Earth, they just positioned this chicken nuggets such that it looks like the Earth. And then if you look at the description of GPT, it clearly figures out that the person who posted this picture is making a joke with this chicken nugget. You can also draw, the model can also draw, even though the model was never trained to draw something. Somehow it learns how to draw something. And if you ask the model to draw a unicorn using some programming language for drawing something, it's called ticks, and then it will generate some program code. Once you get the program code returned by the GPT, you can actually compile it to draw the figure. And this is the unicorn drawn by GPT-4. You can also ask the model to write a poem, which also requires the clear understanding of prime numbers, or the fact that there are infinitely many prime numbers. And look at the, this is the poem that's written by GPT-4 about infinitely many primes. Also, if you give the series of data and then ask the model to analyze it, it can draw figures and it can draw data analysis. If you give some really difficult math problem, they can also solve it. It's like math Olympiad type of questions as well. And if you ask the model to write another poem on KSEA and GPT, you can ask the model to write both in English and Korean, and this is the output of the model. You can see that pretty good poem, probably better than me. I can write this good poem. All right, so as I mentioned, that's it. That's all about how GPT works and how smart GPTs are. And I'm gonna briefly touch upon how they will change our lives as a scientists and engineers, and also how it will impact the entire society. So for the science engineering, I think it's fairly easy to see what will affect, how this model will affect scientists and engineers. So let me explain what that means. So there's a paper that came out 2 months ago by the company OpenAI and also some other collaborators. They took a look at the GPT-4 before they release it, and they wanted to study, before they release the model, they wanted to study how this model will change the world, particularly focusing on the labor market. And this is the conclusion. 80% of the US workforce will get some impact, will have some impact by the GPT-4, by having 10% of their work pipeline being affected by GPT-4. Okay, 10% is fine, but what's surprising here is about 20% of workers, half of their work will be impacted. In other words, if you're working for, let's say, 8 hours a day, probably 4 hours of work per day could be completely replaced by GPT-4. That's what this report is reporting. And in fact, there's a huge correlation between higher income and the amount of tasks being impacted, which basically implies that white-collar jobs are going to be more affected than more, let's say, physical-based jobs, like blue-collar jobs. So here's an example. Software engineer or programmer that is considered a very good job these days. And what they do is they do program, but you can see that a lot of tasks that we are doing, or as a software engineer, I'm also like programmer myself. What we do is like detecting bugs, review the code. But in fact, all of these tasks can be easily done by GPT-4 or even better models later on. In fact, what's super surprising is the model itself can actually write pretty good code. We don't even need any program to start with. So here's an example. This is called Copilot. That is, it's kind of like program-specific language model. You can see that, think about you're a programmer. You write down what you are going to write in natural language. I want to generate a function that retrieves the database items. And you see that it suddenly gives you the code. Okay, so the first green line is what human programmer is writing. But then after that, then the next 10 lines of program code is instantly generated by the GPT model. So as I mentioned, I'm also working with a Korean video game company, Krafton, and I would say more than half of the programmers there are already heavily using this Copilot model. And we have already seen a huge increase in productivity, as well as there's another report that has evaluated how much productivity changes are coming from GPT-4 or this kind of code models. They showed that 3x, 4x productivity gains are expected from these models, which means that there will be probably like much less demand on this kind of jobs. What about data science or data analysis? So look at this. This is the new browser interface provided by GPT-4. You can literally upload your file and ask the model to analyze it. And the model just analyzes, hey, there are these columns, this data, this feature, blah, blah, blah. And you ask the model, hey, I want to cluster the data. Can you cluster the data and draw it for me? And the model can cluster the data, run the algorithm for clustering, and they will visualize the output for you. So you should check out this on ChatGPT website if you haven't tried it. This is pretty much mind-blowing, and I feel like most of the standard data analysis or data science pipeline is going to be complete obsolete in a few years. And this is a list of the jobs that are going to be most affected by the report. And you can see that there are a few different scenarios, alpha, beta, gamma. Those are different scenarios. But no matter which scenario is going to be the case, you can see that at the top of the list, you can see the scientists, researchers, engineers, and so on, and mathematicians. So I guess that's a warning signal to KSEA, not just Korean science engineers, but probably all scientists, engineers should be really prepared for what's going to happen. All right, with that, I'm gonna just move on to what we should do. First, I guess a lot of people who joined earlier today said They don't like AI. They don't like machine learning. Things are moving too fast. But first thing we need to do is you have to embrace AI now. You have to embrace AI literacy, and you have to acquire and learn basic understanding of the principles. Collaborate with AI. You have to work with AI. Otherwise, you will be behind. And you have to commit to lifelong learning because things are changing so fast. Everything we thought is the case last year is not anymore the case this year. So you have to commit to lifelong learning and fast moving. How will GPT change the society? Just one slide. As I mentioned, automation probably is going to be good, but job displacement is going to change the world. So there's some ups and downs here. Education, I think there's a lot of good use cases of GPT-4 and increasing the education quality everywhere. That's going to be a good thing. But there are so many bad things: misinformation, privacy issues, any kind of misusage that's what we are worried about these days. There was a hearing yesterday at Congress, and we have to make sure that we are not going to make use of this crazy technology in a bad way. So with that, I'm going to put the conclusion slide. The summary, GPT is a really powerful next word predictor. GPT will change the way we do science and engineering. So we have to embrace and collaborate with it. And the last thing is GPT will also change the world. So let's make sure we have to use it right. And the plot twist here is most of the slides that I presented today are literally made by GPT-4. I just asked the model to generate the text for slide 1, slide 2, slide 3, and everything was written by GPT-4. And I just copy and paste it to my Keynote. With that, I would thank for your time and attending my talk, and happy to answer any question. Thank you so much.
Thank you. It's very, you explained, although your slides are made by GPT-4, but I think we heard it's a real you, not GPT image or anything, virtual. So there was a fantastic, you made it very easy for all of us to understand very well. Even I can understand most of what you said. So let's do the following. I know there are already questions in the chat box, and maybe Professor Lee, you can answer, you don't just look around all of them. Perhaps you either summarize or one by one. It's up to you how to answer. While he's answering these questions from the chat box, those who have questions, just raise your hands. And as soon as we go through chat box questions, I'll call you based on order of your hands.
All right. So I go through the questions in the chat box first. So the first question is,
shall we stop share screen so that we can see you?
Oh, sure.
Better? Okay, great.
All right. So I start with the first question. It's from Junki Kim. There's a lot of fake information on the internet, and GPT will output that fake information. That's a great point. So GPT by default, as I mentioned, will grab the random text from the web, and it's going to learn how to generate similar text like that. So if the model is seeing anything fake or sometimes something really bad, like biased information, the model will also repeat the same bias and same fake information. So that's something that I didn't talk about today. So what I talked about today in terms of training is kind of phase 1 of the training. Phase 2 of the training, they actually have to filter out and refine the behavior of the GPT model so that you don't see the model output fake information or generate biased information and so on. So that's a little more technical, so I didn't talk about it, but that's a great question that by default, the model is going to, after phase 1 training, the model literally mimics what's out there, which is a mixture of truth and fake and bias and everything. So I think Junki's follow-up question, can fake train data be removed or filtered out? That could be one possible way to solve the problem. What people are doing right now is, at first they've trained with a combination of clean data and fake data, but then after that, using the post-processing method, they make the model to not generate fake data. All right. And the next question is by Eric. So most likely next word does not imply the truth. Okay, that's the same question. I think the question is about next word prediction may generate fake news and amplify the bias. So that's exactly the same question that I just answered. So by default, the model will do that. So you need a secondary follow-up training process to remove that behaviors. All right, let me move on. So next question is by Daniel Lee. Can the next word predictor be used for logical induction and deduction? That's a great question. So this is something that is, I would say, is kind of under debate. I would say we don't have any clean answer to this question. So even the researchers, societies, the answer to this question is not clear. Can the next word predictor, so technically speaking, the next word predictor that I'm talking about right now is a really big compute machine. So it does a lot of computation before it spits out the next word. So when I say the next word prediction, it's not like very short-sighted next word prediction. What it could be actually doing is inside the machine, they might do a lot of computation before generating the next word. So the next word prediction is just about the format of the output, but we actually don't know how the next word is computed. So next word could be generated after doing a lot of logical induction and deduction, and maybe generates next word. Who knows? So whether the model actually does that or not, that's a still open question, and we still need more research. But I personally believe that with a large enough model, the model is doing some kind of induction and deduction. And there are some evidences that show that the model is able to do reasoning like that. That's a great question by Daniel Lee. The next question is, how do we pick a random internet site? That's a question by Eric O. In fact, I said random internet site, but turns out that the big companies literally take almost all websites on the web. So they don't even consider random text. They take the entire text of the web and use it for their training. So they don't have to figure out which random site to pick. The next question is by Donghyun Ha. Can we make something like a novel by repeating and calculating the next word? That's a great question. Is there any creativity in GPT? So I didn't go into that detail, but when I set the next word prediction, the model not only generates or predict one word, it actually generates the possible next, a list of possible next words. You can think about that way. Not just one word, but it generates a list of possible words that come after that. So in fact, depending on which of those possible next words you pick, there are exponentially many different possible outcomes. In fact, if you have used GPT interface on the web, there's a term called, the technical term called temperature. The temperature is kind of deciding how many candidates you choose from. So if you increase the temperature, you have more diverse output as you use the model. If you use a very small temperature, then the model only outputs one possible next word. So you're right. So when you're doing creative writing, if you use a lower temperature with this kind of model, the output becomes a little dull. But if you use high temperature, then the model is going to give you a few possible output next words. And because of that, your output will be more and more creative. So the answer is yes, you can use next word prediction model or even for creative writing because of this kind of random generated randomness here. That's a great question by Donghyun Ha. The next question is by Ananth. Do I know a good resource for how scientists can use GPT-4? It's a great question. I didn't give any real learning materials that you could start with. I would suggest there was a paper that came to, I think it was ACS Nano, so like chemistry journal, but they actually had a paper, short paper on how to write a paper with the aid of GPT-4. That was actually a very good starting point for people who do research, because you have to write a paper, and how to make use of GPT-4 when it comes to paper writing. A large number of scientists wrote a paper and submitted to, it is already published at ACS Nano. I think it was ACS Nano or some ACS journal, but yeah, that's one thing that you can start looking at it. But I guess you can also easily look up. Here's one other thing. You can actually ask the GPT to ask and find the right resources to study. GPT-4 has also ability to search the web, so they will be able to find the best resources for you. All right. And yeah, then the next question is by Matthew John. As we incorporate GPT's capabilities in our lives, what efforts can we make to formulate the most intelligent and useful question to ChatGPT for us? That's a great question. So people came up with this term called prompt engineering. So prompt is like the input text that goes to the model. They call it prompt. So in a sense that we prompt the model with this text, and the model outputs to that. So this, how to write a good prompt, suddenly became a field of study. So now some people call it prompt engineering, and there's a new job title called prompt engineer at big companies, where you go to that company and all you do is write a good prompt for GPT-4, because writing a good prompt can change the way that you use these models. And if you're good at writing a prompt, you can increase the productivity of your team, or you can develop a new product based on your own prompt. So writing a good prompt is becoming a pretty good skill that you need to have right now. This could change also later on, because the model might be less sensitive to how you write prompt. But right now, the current technology is pretty sensitive on how you actually write down and spell out the prompt. So prompting is a good thing to learn. And there's a Stanford professor, Andrew Ng, who is kind of like the father of machine learning these days, deep learning. He has a new course on prompt engineering. So he has a dedicated course on how to write good prompts. You can search for prompt engineering by Professor Andrew Ng, and you can start from that.
So Professor, can we now go to a few physical
Sure,
hands,
yeah.
then we can come back. There was
Sure.
we have to ask GPT how I can pronounce Machi. I cannot pronounce, but you see that.
That was perfect. Thank you.
That was perfect. Great.
Yes. Thank you for the talk. It was very interesting. I have a technical question. So since the data for training is taken from the internet, and as you just mentioned, most of the internet is just taken for training, how do you think we'll make progress in these models? Is basically any data that is from 2023 and later, it is likely to be contaminated by text generated by models like this? Can we train on some kind of unknown mix of human and generated text and expect some improvement?
That's a really great question. I think we don't have any good answer, to be honest, right now. So in fact, one of the biggest challenges we are facing in this training, the next version of this model, we already know that we have completely exhausted the data source we have on the web. And you're right, the rate at which we generate new clean text is very slow compared to the kind of gibberish data or generated fake data by these new models. So I guess, where can you get more data? People are actually thinking about how to generate synthetic data using this kind of models, even though it's not real data, but maybe we can mimic the patterns of the real data we have and generate more realistic, semi-realistic, semi-real, semi-fake synthetic data, and make use of those data to improve the model's performances. That's one way of doing it. The other way of doing it is, well, we have to somehow give up the hope of having more data, because technically speaking, we are not going to have too much data. In fact, one of the efforts made by OpenAI, or it's kind of like conjecture that OpenAI kind of used up the text data. So now they went to the videos, they went to the YouTubes, probably crawled some videos on the web, and then they started transcribing all these videos because they were running out of text data. So the next source was videos, and they had to develop their own transcription, transcribing algorithms to transcribe all these videos. And then you get the new source of text data from there. So probably you can go after audio and video sources left there. But after that, I don't know. So that's a big challenge that we have. And we clearly know that we need more data for now to have a better performance. But yeah, that's a great challenge that we have.
Thank you. Yeah, the video and audio is very interesting. Thank you.
Okay, you mentioned about hearing yesterday. You have any take-home messages we got from that hearing?
I guess like one reaction from the society was we didn't expect that the CEO of OpenAI, Sam Altman, was going to agree that we need to have some controls over development of AI models, because they were the ones that have been pioneering this field, and they were the ones who are like rushing in front of everyone, and like they have like made this scene, basically opened up entire scene of GPT and language models.
Oh, just before, maybe many people may not have heard of, may not know what we are talking about. Maybe could you give a little bit of a short background and about what we are talking about?
Oh yeah, sure. So yesterday at Congress there was a hearing, and the CEO of the company OpenAI, which is the creator and operator of GPT-4, showed up, and they had like several hours of discussion and hearing from him. And the hearing, the goal of the hearing was because there are so many things happening these days, and the Congress wanted to hear about potential risk of these models in the society, to the society. And they ask all these details about how the company is working and how the company is developing the new models and how these previous models were developed and what their plans are and so on, and what their opinions are. And the CEO of the company answered these questions. But the key takeaway message was he himself also agreed that now we need a regulation. For the last 5 or 6 years, OpenAI, the company itself, was the kind of like the symbol of like unrestricted development of language models, and they were at the frontier of this GPT development. But now even themselves are scared, I would say, or at least they are also scared of someone out there. So they believe that we need some regulatory regulation on who can develop these models, and they are kind of like agreeing with what the Congress would like to do, that they can have some controls over what the companies are doing. And basically, some people say this is no different from letting the private companies develop nuclear weapons as they want, which shouldn't be the case. And I kind of agree with the argument, because who knows, the potential scenario, risky scenario is that at some point, one of the private companies build a model that is even much smarter than what we have right now, let's say GPT-5 level. I don't know what that means, but then this model is just too smart to come up with whatever new weapon that we cannot even imagine right now. Then that could also give us some kind of crazy power differential between the companies or maybe between the countries, and that could lead to a new war in the worst case. So that kind of risky scenarios were studied and considered, and the companies are also willing to share the sentiment with Congress. So yeah.
Okay, thank you. So now I don't see any other hands on the screen, so we can go back to the chat box. I think we ended at Matthew. We may not be able to go all of them, so we have about 7 minutes or so before raffle.
Sure. Yeah, I do my best. Yeah.
Okay.
So the difference between Google's Bard and GPT, that's the question by someone, Kim. Both Bard didn't explain, or at least they didn't release the details about behind the Bard. We believe that the neural network architectures are almost the same with some minor differences. The only difference probably comes from the data they use for training, as well as the secondary training part where they make the model a little bit more human-friendly, less biased, less prone to generate fake data. So that second part is becoming more company-specific know-hows. And OpenAI has a really good know-hows to make that happen. So that's why ChatGPT became super popular. Bard was really bad at it, the secondary process. I think Bard has now caught up a little bit. So the new Bard that just came up, it seems to be pretty good. But we don't know those details right now because they stopped releasing those details about, especially the second part of the training. But the utility in applications, there's absolutely no difference. The next question by Vincent Ng. I mentioned the video game programmers are already using GPT for coding. Does this also apply to the art department? That's a great question. So art department, if you're making 3D models and generating textures, some people are more like doing manual work, like artists. There are some job titles like TA, like tech artists, where you do kind of programming to do your 3D modeling work. If you're doing some kind of programming for your 3D work, yes, definitely you can get benefited by using these models. If you're mostly doing artwork by hands or by mouse, you can also benefit by, not by the language models, but by the models, something like diffusion models or image generation models, which is a different topic that I'm happy to talk more offline. But yeah, there's another AI tools that could also benefit the AI fields. So you should definitely look into other tools as well. All right, great question. Edward Jung, how can GPT be used to better education? So for instance, GPT is a really good English Korean translator. That's what I mentioned. But that basically means that you can make GPT and into a perfect free English tutor. So let's say you are a Korean student. I'm born in Korea and grew in Korea. And it was always difficult to learn English because it's expensive and it's difficult to find native speakers to learn. But what you can do is you can actually literally connect the GPT-4 with the text-to-speech model, and you can actually make a native speaker for free. And the native speaker is there for you for 24 hours. They can teach you anything you want. And in fact, you can switch the language if you want anytime. And that's pretty cool. So that kind of makes the education or cost for this kind of education much lower. And that's just one example. There are so many other examples like that. I guess Sungkwon Kang also raised the hand, so maybe I can go to Sungkwon's question first.
Yeah.
Okay. Thank you, Professor Kangwook Lee. It's excellent talk. I really appreciate. I have additional comment on Senate hearing yesterday. There were 3 witnesses invited. Obviously, one of them was, the CEO of OpenAI, Sam Altman, and second person from industry is from IBM. It was Vice President Christina Montgomery. She representing the industry, and since IBM, has led a lot of research on AI, and also they concern about the security and misuse of that. And third witness was from university, and I have by scanning through this, the photographs, I think it's a majority are senior person like me, and interested in GPT rather than young generation. That's interesting. We're learning, this new technology from young generation like you. So I really appreciate. And in that regard, I have one quiz for you. Since I'm not computer scientist, I'm a hardware guy, but I have a quiz most of the time to computer scientists. you use the terminology like machine learning many times. You know who has coined this machine learning?
That's a great question.
I found most of computer scientists fail this quiz. Maybe Dr. Jungi Kim, former IBM, you can answer that question. Your microphone is...
I don't know about machine learning, but artificial intelligence was coined at Dartmouth College about 55 years ago at the meeting.
No, if you just Google it, you'll find out. I'll give you an answer. The answer is Arthur Samuel. The reason why I'm asking this is he was IBMer while he working IBM, you know, the Poughkeepsie, and that year was 1959. 1959, he already coined machine learning. Then why he's not much publicized as ex-IBMer? Because after he retired from IBM around 1965, he joined to Stanford, a computer scientist as faculty. So he's known as Stanford's professor, but not ex-IBMer. So this is the point I want to bring up, okay? So even you mentioned that the Stanford, you know, professor who giving this prompt engineer, I forgot his name.
Andrew Young, yeah.
Yeah, Andrew Young, his, you know, the introductory course on machine learning or AI, he's showing this one slide about Arthur Samuel, but he didn't mention he was ex-IBM when he, you know, the work on this machine learning. Yeah. Okay. Thank you very much again. Yeah.
All right. So we have 2 minutes left, and we have to do raffle. So I think there are very good questions and also brilliant answers. So I think we got all the flavor of what people have in mind. So let's thank Professor Lee again for today's inspiring presentation and conversation.